Yes, we expect James Webb to make great discoveries. We expect that.
In a discovery that has shaken the foundations of planetary science and astrobiology, the James Webb Space Telescope (JWST) has detected definitive signs of alien life on Mars. This monumental revelation comes after decades of speculation, curiosity, and relentless exploration of the red planet. For years, humanity has gazed toward Mars with hopes of ancient rivers, hidden microbial life, perhaps even the remnants of a long-lost civilization. But no previous mission, neither the pioneering rovers nor the orbiters circling high above, have ever uncovered such decisive biological markers as the JWST has now revealed. The implications of this detection are both staggering and exhilarating, placing humanity at the edge of an unprecedented era in space exploration and redefining the boundaries of life in our solar system. Before we start, smash the like and subscribe buttons for more updates. The discovery began with a series of coordinated observations targeting a specific region near the equatorial zones of Mars, where earlier missions had hinted at potential subsurface reservoirs and curious methane spikes. The James Webb Space Telescope, designed to peer deep into the infrared spectrum with an unmatched sensitivity, was initially being used to analyze atmospheric compositions and thermal emissions from planetary bodies within our solar system. When its instruments focused on Mars, the data returned revealed something extraordinary, an unusual combination of gases, chief among them methane in seasonal cycles coupled with phosphine and other organic compounds that could not be explained by geological processes alone. Phosphine, in particular, has been considered a potential biosignature gas, as its production in meaningful quantities typically requires biological activity in environments similar to Earth's anaerobic ecosystems. The presence of this molecule in Martian atmospheric layers, in conjunction with the detection of certain isotopic ratios of carbon and hydrogen, strongly suggests that biological processes are active beneath the surface. Even more compelling was the spectral fingerprint of complex organic molecules that, when analyzed further, displayed the patterns consistent with metabolic byproducts, an unmistakable sign of life. What made this finding even more significant was that it originated from a region of Mars not typically considered the most promising for life detection. Unlike the ancient lake beds or recurring slope lineae previously studied by rovers like Curiosity and Perseverance, this location was geologically stable, relatively arid, and not part of any known ancient water system. Yet JWST's powerful infrared instruments could penetrate the thin atmosphere and identify chemical signatures escaping from fissures and vents in the crust, hinting at a deeper, hidden biosphere below the Martian regolith. The implications of such a discovery cannot be overstated. If life can persist beneath the harsh, frozen, and irradiated surface of Mars, it raises profound questions about the universality of biology. It suggests that life is not an earthbound miracle, but a cosmic inevitability. Mars, a planet once thought to be sterile and long dead, is now known to host life, alien life that evolved in conditions vastly different from Earth's, yet capable of leaving detectable chemical traces across the thin Martian air. Furthermore, the nature of the detected life forms, though not directly observed, can be inferred from the metabolic gases they emit. Based on the observed chemical ratios and thermal data, scientists believe these organisms are likely microbial in scale, potentially analogous to extremophiles found in Earth's deepest caves, hydrothermal vents, or Antarctic subglacial lakes. These life forms may derive energy through chemosynthesis, feeding off mineral interactions in the crust rather than sunlight, which would be consistent with a subsurface ecosystem cut off from the surface for millions, if not billions of years. This finding shatters the long-standing paradigm that habitable zones must lie within narrow temperature and water constraints. If life has found a foothold on Mars, then the entire classification system of habitability must be reconsidered. Moons like Europa and Enceladus, with their icy crusts and suspected subsurface oceans, now seem even more promising, and exoplanets, once judged uninhabitable due to surface conditions, may harbor rich biospheres buried beneath. The discovery also catalyzes a deeper philosophical inquiry into the nature of life and its origins. If life independently arose on Mars, it would confirm that abiogenesis, the process by which life emerges from non-living matter, is not a rare fluke but a fundamental outcome under the right conditions. Alternatively, If Martian life shares a common ancestry with Earth life due to ancient asteroid-mediated panspermia, it would provide physical evidence for the interplanetary transfer of life. Either scenario radically expands the scope of biology from a planetary to a cosmic science. From a technological standpoint, this breakthrough is a validation of the capabilities of the James Webb Space Telescope. Originally designed for deep space observation of galaxies, black holes, and the early universe, JWST has now proven to be a revolutionary tool in planetary science. Its infrared sensitivity and spectroscopic instruments can detect trace gases at unprecedented precision, enabling it to analyze planetary atmospheres and surfaces even from millions of kilometers away. This has opened a new era of remote biosignature detection, allowing scientists to examine distant worlds not by sending landers or rovers, but by interpreting the molecular echoes of life through light. Mars itself, long a subject of robotic exploration, now demands a reimagined strategy. The presence of alien life, even microbial, introduces a complex ethical dimension to planetary missions. Contamination risks, both forward from Earth to Mars and backward from Mars to Earth, must now be addressed with renewed urgency. Future missions will need to incorporate advanced sterilization protocols, biocontainment strategies, and perhaps entirely robotic sample handling systems to avoid ecological disruptions. There is also the issue of accessibility. The Martian subsurface, potentially harboring vast colonies of microbial life, is not easily reachable. Current drilling technologies on Mars, while advanced, are not yet capable of penetrating deeply enough to reach the full biosphere. This discovery will likely accelerate the development of deep-bore drilling missions, potentially involving nuclear-powered rovers or AI-guided subsurface explorers that can navigate through the crust and relay data from beneath the surface. Beyond science and technology, the cultural and psychological impact of this discovery is seismic. For the first time in history, humanity knows that it is not alone. Not in terms of intelligent life, perhaps, but in terms of the existence of life beyond Earth. The existential solitude that has pervaded human thought since the dawn of time has been challenged. The implications extend into philosophy, religion, and our collective self-perception as a species. If life exists on Mars, however simple, then the cosmos teems with potential, and the long-standing belief in Earth's biological uniqueness collapses. This also reshapes the trajectory of future exploration. Mars is no longer merely a target for colonization or terraforming, it is a world with its own ecosystem, however rudimentary. The presence of life imposes a responsibility on humanity to approach with humility and care. Every rover track and drill site now carries the potential to interact with or disturb alien biology. This will fuel debates on planetary protection, conservation, and the moral frameworks of interplanetary stewardship. Governments, private space agencies, and international coalitions will now face a new frontier not just of exploration, but of policy. Treaties and regulations surrounding the treatment of extraterrestrial life, the ethical limits of study and sampling, and the commercialization of biologically active worlds will need to be drafted or revised. The discovery of alien life forces humanity to consider itself a participant in a broader biosphere that spans planets, possibly even star systems. Back on Earth, laboratories are already racing to model the atmospheric data returned by JWST. Simulations, chemical replication experiments, and even synthetic biology projects are underway to understand how these alien microbes may function, how they adapt, and how they evolve. This marks the beginning of comparative exobiology, a science that not only studies life as we know it, but life as we are only beginning to understand. Public enthusiasm has surged as a result of this announcement. The notion that Mars, so close, so visible in the night sky, is home to life has captured the imagination of people across cultures, ages, and professions. Artistic interpretations, speculative fiction, and scientific curiosity are now interwoven in a renaissance of interest in space. Children look up at Mars not as a dead rock, but as a living neighbor. The red planet, once a symbol of desolation, is reborn in the public mind as a cradle of alien biology. This finding also reinforces the importance of continued investment in space science and interplanetary research. The detection of life on Mars justifies decades of funding, research, and exploration efforts that may have once seemed speculative or premature. It serves as a clarion call to persist, to explore further, and to unlock the mysteries still hidden in our solar system and beyond. In the aftermath of JWST's detection, the roadmap of humanity's space exploration is being rewritten. Missions once aimed at geology or atmospheric studies are now being reconfigured with life detection instruments. Biologists, chemists, physicists, and engineers are joining forces in interdisciplinary teams to tackle questions that no single field can answer alone. Mars is no longer just a scientific destination. It is a biological frontier. The search for life, long a philosophical endeavor, is now an empirical reality. Mars is alive in its own way, with alien biology breathing, perhaps slowly, perhaps invisibly, beneath its dusty plains. The cosmos has whispered back to our centuries of questioning, and the answer is yes. Life is not unique to Earth. It can emerge under different suns, on different soils, and in different forms. The universe, it seems, is not just a place of stars and silence, but of seeds and symphonies waiting to be discovered. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on James Webb detecting alien life on Mars? Real or hype? We want to hear from you. Thank you for watching, and see you next time.